Hi, welcome to the Olympiad geometry. Let's continue our study on Incenter. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe the channel. Here is the problem. M is a midpoint of edge BC in triangle ABC. I is incenter. AH is altitude of BC. E is the intersection point of line IM and AH. Prove that AE's length equals to the radius of inscribed circle. So the radius of the inscribed circle is actually the distance from I to three edges, right? So we can, because we have a AH perpendicular with BC here, so we can just find the tangent point of the inscribed circle with edge BC, right? We do the projection from I to the BC, and we find the foot as F, let's call it. Right, so basically we want to prove that AE equals to IF, right? We want to prove AE equals to IF. One way to think about this problem is that we already know IF is in parallel with AH, right? Because they are both perpendicular with BC. And if IF equals to AE, that means AIFE is a parallelogram. So instead of proving that IF equals to AE, we can prove AIFE is a parallelogram, which means that we can connect EF. And we can just prove that AI is in parallel with EF and AI equals to EF. And then we're stuck. Because this is difficult to prove, right? Because if you want to prove that two lines are in parallel, you need to find the relation between these angles, which is difficult here. So for this problem, it's a little bit tricky because you can calculate it, right? So let's just do this way. It's like it's like a false Bluetooth solution, right? We calculate everything out and then we prove. So the first thing is that M is a midpoint of BC. So we know that BM equals to MC equals to half of A. And we know that IF is perpendicular with BC, right? And AH is perpendicular with BC, which means that IF is in parallel with EH, which means that triangle IMF is similar to triangle EMH, right? That means the ratio of IF to EH equals 2. Because IF is R, right? That's the radius of the inscribed circle. So let's call it R. IF to EH equals to MF to MH. Right? And how can we calculate the MF and MH? So, because we already know that CF is a tangent of the inscribed circle. Let me maybe draw it. Then it would be easier to think. Right, that's the inscribed circle. So, in previous tutorial of the Incenter property, we already introduced that we can calculate the CF easily, right? So CF is actually equals to A plus B minus C divided by 2, right? So we know the length of CF, we know the length of CM, then we know the length of MF. For MH, we already know the length of CM, so we need to know the length of CH in order to calculate for MH, right? And how can we get CH? CH equals to AC times cosine C, right? And cosine C can be calculated with using the cosine theorem that C squared equals to A squared plus B squared minus 2AB cosine C, right? That means cosine C equals to A squared plus B squared minus C squared divided by 2AB. So we got CH equals to AC, which is B, right? B times A squared plus B squared minus C squared divided by 2AB equals to A squared plus B squared minus C squared divided by 2A. That is CH, right? So now let's see this MF to MH. MF to MH equals to, what is MF again? That is MC minus FC, right? MC minus FC 2. And what is MH? That is MC minus CH. So it equals to A by 2 minus FC. FC is this one. So A plus B minus C divided by 2. And 2 MC, which is A by 2 minus CH. CH is this one. So A squared plus B squared minus C squared divided by 2A. Right. So it equals to, we times 2A to both top and bottom. Then we got A squared minus A squared minus AB plus AC divided by A squared minus A squared minus B squared plus C squared, right? It equals to AC minus AB divided by C squared minus B squared, which equals to AC minus B divided by C plus B, C minus B, right? And that is MF to MH. And based on this, we already know the MF MH, so that equals to IF to EH, right? So EH to IF would be the flip of this one, so C plus B, C minus B divided by A times C minus B. Right, that is a flip of MF to MH, right? So we got EH equals to C plus B, C minus B divided by A, C minus B times IF. IF is radius R. So it equals to C plus B divided by A times R. Right, in the case that C, the length of AB and the length of AC are unequal, right? So C isn't equal to B, right? So that's it. That's a case. We can cancel C minus B. We will talk about that special case later. So we got this one. So EH to IF equals to C plus B to A times R. Right, we got that EH. Because we already got EH and we know the length of AH, AH is AH equals to A plus B plus C times R time half of it divided by, that's the area, right? Divided by A, half of A, right? That's the AH, that's the altitude. So A equals to A plus B plus C times R divided by A, which means AE equals to AH minus EH equals to A plus B plus C times R divided by A minus B plus C times R divided by A, which equals to R. Right. And now let's look at back the case that C equals to B. When C equals to B, that means M and H are on the same point, right? Which means we cannot get MI intersected with AH. So this would be an invalid case for this problem set, right? Okay. So this problem is a problem that we need to do the brute force calculation to figure out how to prove it. It's not an easy one if we just want to prove the problem through that the angle itself. Okay, I hope you like this video. See you in next one. Thank you.